Let us look at the esters and predict the possible chemical, the possible proton NMRO for them. So we have H, something like this. This is an ester. Then you have O, C double bond O. Here we have H, H. Here is H. And then we have to predict the NMRO spectrum for this. Now, how do you predict the NMRO spectrum for this? It becomes very, very easy. Now, first of all, we know the 0 point here represents TMS. All right, and then we are going to label. Now, we can say let here be A, here is B. Now, how many signals are we going to first of all see? Because you know, these protons here, we give a signal. This one's here, we give a signal. No signal here, no signal here. And then this one is going to give a signal. So we have to see 3 signals. Let's start with A. By virtue of what we know, we said that whenever you have A, neighboring carbon is what you look at. How many protons does it have? It has 2 protons, plus 1, making it a triplet. So you're expected to see a triplet at around 0.9. So what would that triplet look like? Since it will be somehow high, so you're going to have something like this. Then you're going to have 2 stuff attached here, 2 other signals smaller than that. All right, attached of the same height. Now the next one is this one here, B. Now if you look at B, the neighboring carbon is having 3 protons. This one no this thing. So 3 proton, which will be a triplet. So I mean 3 proton plus 1, making it 4, which is going to be a quartet. But CH2 actually absorbs at around 1.3. But because of its proximity to this oxygen, we are going to see it at around let's say a proximity to oxygen. If you come and look here, proximity to oxygen is going to be around 3.5. Are you getting it now? 3.5, which is around, let's just say it goes as far as 3.5. It's going to be a what? A quartet. Now I told you that for quartet, you are going to have 2 peaks that are of equal height, and then you are going to have 2 other peaks that are of equal height. So you call this a quartet. Then the last one is this CH3 group here. The carbon adjacent to it has no proton. So our N is 0. 0 plus 1 is 1. So it's going to be a singlet. The CH3, the chemical shift value is supposed to be at 0.9. But because of its proximity to this carbonyl group, we are going to see it at around, let's say, 1.5. Now, like we said, you are not to have the exact values. It's a single peak, so it's going to be very high, very well, because it's CH3 too. So this is the structure we are expected to see for this particular one. Now, same thing applicable to any other compound that will be given to you. Depending on the nature of the compound, you're still going to work it out in this way. All right, think that is that. All right, so that is that. Now, any other one that is given to you, let's check for the isomer of this. You have C, H, H, H. We have C, H, H. We have C, H, H. Then you have O, C double bond O, and this is H. Now, what are we expected to have? We draw our something like this, and then we start labeling. Told you, somewhere around here will be A, here will be B, here will be C, here will be what? D, because this one here is carrying a proton. So you are going to see 4 peaks, right? Now the 4 peaks you are going to see for this first one is going to be around 0. This is of course 0, so it'll be 0.9. The neighboring this thing is 2 plus 1, a triplet. So you are going to have a triplet here. This is no longer new to us again, so I will be a little bit fast. Right? Now for B, we have two neighboring carbons. The two neighboring carbons, this one have 3 protons, this one has 2 protons, which is 5 plus 1 makes it 6. And CH2 is around 1.3. So you are going to have this at 1.3. Is 6 sextet. Now I told you that for sextet, you look at it, it's based on CH2. It's not as high as this. For sextet, what you are going to have would be 2 lines that are of equal height, right? Then you are going to have 2 other lines that are of equal height. Then you are going to have 2 other lines that are of equal height. All right, so that is that. Now the next one is C. To this side, no oxygen. To this side, no hydrogen. To this side, there's a carbon with 2 hydrogens. Plus 1, 3, making it a triplet. But it's close to this oxygen here, so you are going to see it around 3.5. So we come to as far as 3.5 to put this one here. You are going to have a triplet, because this one is the 2 hydrogen plus 1 making it 3. So it's going to be a triplet almost the same height as this group here. So you are going to have something like this. All right, and then the last one is this carbon here. If you look at it, the adjacent to this side is oxygen. The adjacent to this side is nothing. Are you getting it now? And is an aldehydic proton. Are you getting it? Of course, you are going to, let's just say, is attached to, it's a carboxylic acid, not aldehyde, attached to this carbon. So you are going to see it somewhere within this region here as a singlet. Not that high though. You are going to see it as a singlet. So here is A, here is B, here is C, here is what? Is D. So that's basically what you are going to do for every other one that is given to you. Is that okay? All right. Sorry about that. That last this the question we just did now, there's something cleared off. Supposed to be, we have H, C. The last peak we added, we are supposed to add it at the extreme. Now I'm going to explain why we added it at the extreme, because of anisotropic effect. It's an aldehydic. You hear me mention something like it's an aldehydic proton. It's actually directly added to C double bond O. Are you getting it? The proton is directly attached to a C double bond O. So based on what I've explained before, we said this is A, this is B, this is C, this is D. I've explained these other ones before. We said this will be 0.9. 0.9, what are you going to see there? A triplet. Should be something like this. Right? Good. B, we are going to see a sextet at around 1.3. Right? Sextet will be something like this, according to what I told you. And then I said something about this group here to be around 3.5 because of its proximity to this group, or let's say at around 4. But it's also going to be a triplet, which should be something like this. I've explained this before. And the last one, this one, this is an aldehydic proton. The proton is attached to a carbonyl group, and I explained something on anisotropic effect. What you'll be expecting it to be very far from like around 9 points or even 8.0. So you are going to see this one at around 8.0. This singlet, you're going to see it at around what? 8.0, not where I positioned it before. That is the only correction I wanted to make in this one. So this one will be around, let's say 4.0. This one will be around 1. Okay, it's close to 1.3. That is 0.9. So that will be the structure that will be given to you. So whenever you see any aldehydic proton, you know where to keep it. Very far away. All right. So that's basically that for this one. Now let's see for aromatic. Or let's leave it. With this understanding, you should be able to understand the practical work now. So let's go to the practical aspect of it.